Right, in this bookwork, it's the last one. This is one we're doing applications. Um, do 38 through 50 even, except for number 46. All right, I'm going to do number 40. All right, number 40 says the plane takes off at an angle of 6 degrees. All right, so here's my ground. Plane takes off at 6 degrees. So this right here is 6 degrees. Traveling at a rate of 200 feet per second. So this is 200 feet per second. All right. Now, since they're telling me it's traveling at a rate, I'm most likely to be working with distance equals rate times time. Okay. If it continues on this flight path at the same speed, how many minutes will it take to reach an altitude of 8,000 feet? All right, so they want to know how long it is going to reach to get here. All right. Well, we know, excuse me. All right, so if I take this, make this a smaller triangle, this is 200 feet. Okay? And this right here is just in 1 second. I want to know how high I am in 1 second. All right? So I'm going to use my trig. All right? So I want to find this value, or in other words, the opposite side. Since I'm dealing with opposites, so it's sine. Sorry about that, folks. All right, so I'll do sine of 6 degrees is equal to x over 200. All right, so multiply both sides by 200. So I get 200 sine of 6 degrees is equal to x, and that is approximately 20.9 feet per second. Right? So in 1 second, I've gone 200 feet, the plane has gone 200 feet, and it reached a height of 20.9 feet. That's just in 1 second. Right? What I need to find out is how many seconds, or in this case it says how many minutes will it take to get to here at 8,000 feet high. Well, we know if I take 8,000 feet, divide by 20.9 feet, because this is per second, so if I divide this, this will tell me how many seconds it reaches that. So when I divide, I get approximately 382.75. Right? So it takes 382.75 seconds to reach the maximum, to reach the altitude of 8,000 feet. So they're asking for how many minutes. How many minutes? I got to convert these seconds to minutes. So to do that, there's 60 seconds per minute, so I divide by 60. That gives me approximately 6.4 minutes. All right. That was for number 40. Let's look at number 42. Ruth is flying a kite. Her hand is 3 feet above ground level and is holding the end of a 300 feet kite string, which makes an angle of 57 degrees with the horizontal. How high is the kite above the ground? Okay, here's the ground. All right, the girl's standing. Ruth, assuming that's a girl. She's flying a kite. Okay, so here's my kite. All right, isn't that beautiful? All right. So, let's see, she's holding the end of a 300-foot kite string. So this right here is 300 feet. Okay. This right here is height to the ground. All right. So her hand is 3 feet above the ground. Okay, so this right here is 3 feet. Okay. And she's holding the end of the kite string, which makes an angle of 57 degrees with the horizontal. Well, this right here is the horizontal. That's what's parallel to the ground. Okay, so they're telling me it's 57 degrees. So this right here is 57 degrees. This right here is 3 feet. They want to know how high is the kite above the ground. So I want to know the total distance. Well, I know this is 3 feet. I just got to find this value. And then I can just add 3 feet to it, and I found the total height. So again, opposite over hypotenuse, so that's sine, to be sine of 57 degrees is equal to x over 300. So then I get 300 times sine of 57 degrees equals x, which is approximately 251.6. Now remember, make sure your calculator is in degree mode when you're doing this. So it's 251.6 feet. All right, so that's how high it is from here to here, but I want from the ground, so I got to add 3 more feet to that. So I got to do 251.6 feet plus 3 feet gives me a total of 254.6 feet. Will be your answer. All right, let's do one more. Let's look at number let's see here, 48. Right, 50. I was debating whether to do 40 or 50, but I'll be back on Monday, so I'll probably go over this one on Monday with you. All right, because you probably have more questions. You can ask me when I'm actually here. All right, so let's go. I'm going to do 48. All right, a plane passes directly over your head at an altitude of 500 feet. All right, so here's the ground. All right, I'm standing. So from right here, the plane is flying. That's the smoke coming out of the plane. All right, so this right here is 500 feet. 2 seconds later, you observe that its angle elevation is 42 degrees. So that means, let's say it goes to here. It takes 2 seconds to get there. Then you observe, so this right here is 90. So you observe, 2 seconds later, you observe that the angle of elevation is from where you are standing, all right, and looking up. So you have a horizontal, all right, angle of elevation is from here, and you're looking up. So this right here is 42 degrees. How far did the plane travel during those 2 seconds? That's what we're finding, x. Okay. Well, a couple things we know about geometry. We know this is going to be 500 feet. That's 90. Here's x. So this means this would be the same thing because it's a rectangle. All right, so here I have my triangle, have my angle. I'm given this is adjacent, and I want to find the opposite. The opposite. So that means I am working with tangent. So the tangent of 42 degrees is equal to 500 opposite over adjacent. All right, so now we get x equals tangent of 42 degrees is equal to 500, and then divide both sides by tangent of 42 degrees. So x is equal to 500, tangent of 42 degrees, and that is approximately 555.3 feet. and that's your answer.